So we are going to talk about dimension analysis. We're going to talk about okay, a lot of things, just not only dimension analysis, but we're going to talk about just physics in general because these questions are just combined. But the first question is coming from dimension analysis, and the question goes like this. Okay, so this is section A, which has always 40 marks. So it's 20. So one question has got 2 marks. So the question goes like this: the force F between two point charge q1 and q2, a distance r apart, is given by the equation F is equal to k times q1 times q2 over r squared, where k is constant. What are the SI unit? What are the SI base units of k? Do you guys understand that whenever we are talking about units, so here are the things we are talking about. F is given by k q1 q2 divided by r squared. Now k is constant and they want us to find the units for k, but now we need to find the base. Okay, the base units. There are two things that we are supposed to know, right? There is base unit and what? There is base unit and derived, right? So we have got what we call basic units and derived. So you can mute your mic because you'll be disturbing your friends. So there's what we call basic units. For example, I'll give an example of a simple thing. Force is in Newton, but Newton is not a basic unit, it's a derived. Why am I saying this? Because force is equal to mass times acceleration. So force Newton is as a result of kg times meter per second squared. So Newton comes in with the combination. So these are what we call basic units. You don't know how to mute the mic? I don't know. It was you can't see the screen. You can leave the meeting and join again fast, then you'll be able to see it. So what I'm trying to say is there are two things here. So this question, if we read the question is saying, if we read the question is saying from here, look here, what are the SI units? So this word SI base units, so we want basic units, not derived ones. So now what I want us to understand is this: basic units, these are units that cannot be derived. These are standard units, and they are the ones that we use when it comes for dimension analysis. Okay, so for example, not for example, so force, the basic units for force is, we know that force is mass times acceleration. So we'll write this, then mass is in kg, then this is meter per second. So we are going to use this for force. So I'll say force, I'm going to be replacing force with kg times meter. So this second, do you understand that per is the same as negative, right? It's the same as something is on the denominator, so it's the same as this. I think this you know it, right? Do you know that meters per second squared is the same as meters second negative 2, right? Yes. So that's the basic idea. So then another thing is r. We have been told that r is distance from the question. So from the question here, r is distance. So distance is in meters. So I'll put meters. Okay. Then q is a charge. So in case you don't know, charge, which is q, is given by current times time. So current is in ampere, then t is in second, that is time. So what I'm going to do is, the reason why I'm replacing q, now the charge for q is coulomb. Okay, now this coulomb is as a result of ampere times second. That's what it means. It's the same as force, like I said, is newton, but newton is as a result of what? Kgs meter per second squared. So I will replace q, I'm going to be replacing q with as. So a is ampere, s is time, which is second. Okay, what else? That's what we have. K is what we want to find. So let's make k as a subject of the formula. So I'm going to cross multiply. If I cross multiply, I'll be able to have k q1 q2 is equal to f r squared. I'll divide both sides by q1 q2, even here q1 q2. So these they will go. So the constant k will be equal to f r squared divided by q1 q2. Now let's go ahead and replace the basic units. Okay, so k will be equal to, what is the basic unit for f? Is kg meter s to the power negative 2. What of r? So r is meters, but it is squared, so I need to say m squared. I divide it by this q and this q, they are the same, meaning that these guys now they are going to be, so a times s. Now I need to square this because they are two. You know what I mean, right? It's the same as a s times again as. So this as represent another q1, another as represent q2, so which is the same as just squaring them. Tuli mfanaka? You guys from the abroad. mm. I've never seen abroad which doesn't have network. You go to Dubai, then you start experiencing network problems. So what happens now here is going to be k. You can just mute yourself. Anything that is on the denominator, you can shift it to be in front there, as long as it's going to come out as like a negative. So that becomes kg m s to the power negative 2. So what I can do, instead of me wasting time, m times m to the power 3 is m to the power 2 is m to the power 3, then s to the power 2. Now these ones, they are on the denominator. When they come on numerator, they are going to carry a negative, so it will be a to the power negative 2 and s to the power negative 2. But I've got s and s, so those two can add. So I'll have k, the units are going to be kg m to the power 3, then s to the power negative 4 and a to the power negative 2. So these are going to be the basic units of k. Who is behind? So if we go here, which one do you think is our answer? A, B, C, D. Ati? Guys, which one is our answer? Are you telling me it's A? So we have found this. Maybe you're not able to see the screen. We have found k to be equal to kg m to the power 3, s to the power negative 4, a to the power negative 2. So you are telling me that the answer is A. Hmm? The answer is B. So who is behind on how to find the equation? So there will be always a question like this in your exam, whether you like it or not. So it's just a matter of you knowing how to solve it. Is there anyone who is still behind? Hmm? Okay, we go to the next question. You look so confused, but at the same time, you look so organized. People are complaining the network is bad. The network is bad. Mm. Okay, so let's go to the next question. So the next question is very interesting. Very, very interesting. Interesting question. Interesting question. Next question is interesting. So the next question, guys, is saying a particle travels in a straight line with speed v. The particle slows down and changes the direction. Now look at this. You know the fun part about physics is physics is one of the simplest course. You can't compare physics with biology. Biology is even hard. But physics just need you need to understand the question. When you understand the question, the moment you are failing to understand the question, just know that even if you're going to be solving but math there is nothing like I need to understand the question. For example, they just give you a rational function. They just say sketch. Even if you don't know how to sketch to interpret sketching, but you can still do that. But physics now, a particle travels in a straight line with a speed of v. So we have a particle which is traveling in a straight line. Okay? So let's have a straight line here. Okay? So a particle traveling in a straight line. But we don't know whether this is traveling in a straight line. We don't know whether it is in the x direction or y direction. Anyway, so the particle slows down and changes the direction. Get me right there. Okay? The new speed of the particle is v over 2. You get my point there, right? The new velocity has a component of v over 4 in the same direction as the initial path of the particle through which through which the angle has a particle huh? Through which angle has the particle turned. But I want you to understand in this way. Even if you don't understand what it means in a straight line, in this case I'm going to get it in x direction, just like that. Even in the y direction, the answer still remains, it's going to be the same. Now look at this. Look at this. Look at this. Look at this. A particle travels in a straight line with a speed of v. So we have got a speed of v. A particle travels. So now we are going to assume that the initial speed that we have, okay, that's the initial speed, right? So the data that we have, guys, is, let's just gather our data here. So the v initial is actually v. Okay. Now from the question, I want someone to tell me what will be the v final. So the particle slows down and changes direction. Now the particle is moving with v. Now it has changed the direction. Now the new speed of the same particle is v over 2, meaning that is our what? Our final speed. We are together, right? So the v final is actually v over 2. Now I go back to the question. The new velocity has a component of v over 4. Now look at this. The new velocity has a component. How do we find the component in x-axis? Let's go back to vectors. In x-axis, how do we find the component? Hmm? So they are saying this new speed, this one, has a component of what? The component that is going to have is v over 4. So how do we find the component in x direction? Come on, guys, let's do fast. by using cos. So is the now the v final, that's what we're talking about, meaning that what I want you to understand is that it is the v final, is the new velocity. V cos theta is equal to, we have been told that the component is actually v over 4. But what is this v final? This v final is v over 2. That's the new speed. But this is just the component that is going to help us to find this. So I'm going to replace the v final with v over 2. So v over 2 cos theta being equal to v over 4. Now the question is, we need to find the angle, the theta. Okay, so how do we find the theta? So this is what we're going to do. I'm going to do times the reciprocal of this, which is what? Which is 2 over v. Even here 2 over v, meaning that this and that will go, this and that will go. So 2 there, 1, 2 there, 2, then v will go, then I have 1 on top. So I've got cos theta being equal to 1 over 2. So to find theta, it will be cos inverse of 1 over 2. Now look at this. Look at this. So if I get my calculator, I'll find that theta is 60 degrees. So that's the angle. So if I go back to the question here, D is my correct answer. Question 3. The mass of a rocket propelled truck is approximately equal to the mass of the fuel in its tank. So we have got the mass. Before we even finish solving the question, we have the mass of the rocket, so I'll call it M, is the same as the mass of the fuel in the tank. So if I add them, then they will be like this. So they are the same. Okay, the fuel is ignited and the tank is propelled along horizontal track by a constant force. So the force doesn't change. So the force is constant. I'll just write it like that. The effect of air resistance is negligible during the test, or during a test run. The fuel is consumed at a constant rate. Which statement describes the acceleration of the truck during the test run? But let me first explain something. Here is the truck. Now there is fuel. The mass of the truck, or the mass of the rocket, okay, and the mass of the fuel in the tank, they are the same, meaning that the truck is bit heavy. As time goes by, the fuel is going to be consumed. So as the fuel is being consumed, meaning that the mass is becoming less. Newton's second laws of motion. So force is equal to mass divided by acceleration. Let's make A as a subject of the formula. So A becomes equal to force is equal to, guys, you are just seeing me, is force is equal to mass divided by, so force is equal to mass times acceleration, right? Let's make A as a subject of the formula, Newton's second laws of motion. Divide both sides by m by m. So A is equal to F divided by m. Now let's go back to the question. The question is saying we have got the mass of the rocket and the mass of the fuel in the tank. As the time goes by, as the truck is moving, the fuel is going to be consumed, meaning that the mass now has decreased, okay, provided that the force remains constant. What happens to the acceleration? From this formula, if we reduce the mass, the force remains constant. What happened to the acceleration? Do you think the acceleration is going to decrease, or is going to remain the same, or is going to increase? Arrow. What's going to happen, guys? I want someone to respond. The force remains the same, the mass has reduced because now the fuel has been consumed. What is going to happen to acceleration? Is it going to remain the same, reduced, or is going to increase? The acceleration is going to increase. So the best option here is that the acceleration is going to increase. So which one can I? Acceleration remains constant. So acceleration of the truck increases as the fuel is consumed. So that's the answer. So the best answer in this case is B. Now, in case you don't understand, what's happening here is very simple. Let's say we have got someone who is, we have got a Dumbo here, someone who is chubby. Let me not use the word Dumbo, but someone who is chubby. Now there is a force of 50 newtons that we are trying to push, and this object is 65 kgs, and we have this another object with a mass of 30 kgs, and we apply the same force, 50 newtons. What's going to happen to acceleration? That's the basic idea there. So the acceleration remains constant, or the force remains constant, but we have reduced the mass. So acceleration in this case is going to be force, which is 50 divided by 65. So this is going to be 0 point something. It's going to be 65 divided by 50 divided by 65, that is 0.76. So it's going to be 0. I can't see my pen. Okay, it's going to be 0.76 meters per second squared. Now here the force is 15, then 30, 0 0 will go, so A will be equal to 1 point something. So you can clearly see that when you reduce the mass, the force remains the same, the acceleration is going to go up. That's what happens. Now let's go to question 4. Question 4 is under momentum. So here I think it's going to help me to explain also everything on momentum, almost about 60% of what you're supposed to know under momentum. So the question is saying the momentum of the car of mass m increases from P1 to P2. What is the increase in the kinetic energy of the car? So I have gotten the question. They are saying the momentum of the car of mass m increases from P1 to P2. So the momentum of the car increases from P1 to P2. That's what the question is saying. Then it continues to say it has got the mass m. It continues to say what is the increase in the kinetic energy of the car. So what I want you to understand is that let's first come up with we have got two things. So if the momentum is increasing, get me right there, if the momentum is increasing, then we have got the change in momentum. Okay, the momentum is increasing, then we have got the change in momentum P. So the change in momentum is equal to the mass times the change in velocity. So the change in velocity that I'm talking about here, come on guys, the change in velocity that I'm talking about here is the one that is going to, meaning we have got the velocity 1 and velocity 2. Initially velocity 2 is the final velocity, velocity 1 is the initial velocity. So the velocity 1 is going to be for P2, and velocity 2 is going to be for P2, velocity 1 is going to be for P1. As simple as that. Okay, Now the question is, what is going to be the change in kinetic energy? The change in what? Kinetic energy. So how can we find that? The change in kinetic energy is going to be equal to the half mass doesn't change, but because we are changing, the kinetic energy is changing, meaning that the velocity is going to change as well, so we're going to have the change in velocity. Now we square it. Any question there before I continue? Hmm? Guys, so guys, you're not active. Are you dozing? You can be thinking you are dozing. Rebecca, are you in? You are able to get something, eh? I told you to send me the past papers. You didn't manage to send. Okay, I'll be waiting. So what happens here now? We want to get the relationship between this and that. One thing I want you to understand, that the change in momentum is the P2 minus the P1, because P2 is the final. So to find the change in momentum, same applies to the change in V, is V2 minus V1. V2 in this case is the final velocity. Okay. Now to make things simple for you, I'm going to work around with this. So what I have there is the change in P is equal to the M times the change in V. So I'm going to make V as a subject of the formula. Why am I doing this? Because I do not, from the data that we don't have the velocity, but we have the mass. I want to find a way on how I'm going to eliminate the velocity. So from this, since we are going to be finding in terms of the momentum, I need to make V as a subject of the formula. So I will divide both sides by M, here M. So the change in V will be equal to the change in P divided by M. Now in this formula, where there is change in V, I'm going to replace with the change in P over M. Okay, so we can go ahead and do that. So the change in kinetic energy will be equal to half M. Then now what I want you to understand is that in the brackets, because V is squared, so we'll replace it with the change in P. We square it and divide it by M. Now we square it as well, like that. So 1M will go, and here I'll remain with 1M. So what I've remained with is the change in kinetic energy will be equal to half, then the change in P divided by M. But again, another thing we should, P is squared, but remember, where there is change in P, the question is there is no change in P. They want us to represent it using P1 and P2. So the change in P, we replace it with this. So what we'll do is the change in kinetic energy will be equal to P2 minus P2 squared minus P1 squared. Then I divide this, so I'll say 2 times M, it will be 2M. Then this is now the answer. Is it interesting? Yes, very much interesting. Very much interesting. Very much interesting. So let's go back and see if at all the answer we have found here is there. Let's see if it's there. So the best answer is what? Is A. Now, I want someone to tell me why B is wrong. Why do you think B is not correct? Hmm? Why do you think B is not correct? Rabbi. don't know if it's my, I can get you, but your voice is too low, kind of. Uh-huh. Yes, yes. Mhm. Yes. Ah, well, B is also saying final minus initial as well. So in short, what we have here, this one, this one which we have here, this initially, I want you to understand this. When we say change, why am I here now? When we say change in momentum, what I want you to understand is this. The answer that we have found is this. Change in momentum being equal to P2 squared minus P1 squared divided by 2m. What does it mean? Remember what we said. So the change in kinetic energy is the kinetic energy 2 minus kinetic energy 1. So the kinetic energy 2 is actually P2 squared divided by 2m. Then the kinetic energy 1 is also P1 squared divided by 2m. So now since these things, when you are adding them with the denominators are the same, you are just adding the numerator. That's how now we have found this. So this is different from this. It's different from this because this, it simply means it's the same as you have two of these, not so. You have like this. So this one is not correct because we are just replacing 2 with each entity. That's why this one is correct. So it's not supposed to be in the brackets. So that's the reason why this guy is not correct. So this is wrong. So the best answer is this one. Now Mr. Understand, huh? So yeah, now let's talk about so what I'm going to do now, from what I've explained today, tomorrow what I want us to do is I'm going now to be explaining the topics, like everything in the topic. From the basic idea I've given you, then I explain again everything. Now let's talk about question 5. So question 5 is saying a cannonball of mass 3.5 kg is fired at a speed of 22.0 meters per second from a gun on a ship at a at a height of 6 meters above the sea level. The total energy of the cannon is the sum of the gravitational potential energy relative to the surface of the sea and the kinetic energy. What is the total energy of the cannonball as it leaves the gun? So how do we find the total kinetic energy? In this case, we have got only two energy that is present. We have got the kinetic energy and the potential energy. So therefore, the total energy, which is going to be represented by E total, ni ng'ombe, then that is going to be the kinetic energy itself plus the gravitational potential energy. Now, one thing I want us to understand is I don't have enough space this side. Allow me to go this side, but I need to correct data. The mass is 3.5, speed is 22, then the height is 6. These are the only things that I have. So let's write them here. Now, the most important thing that I'm going to help you with is, after reading the question, come up with data. The mass, we can clearly see from the question that the mass is 3.5 kgs, the height is 6 meters, then the speed is 22 meters per second squared. I hope I've not made any mistake. Yes. Another thing that you need to know is we have said the energy total. In that case, they have even mentioned, they are saying the total energy of the cannonball is the sum when you add the gravitational potential energy relative to the surface of the sea and the kinetic energy. Come on, guys. So when you add these two, you'll be able to find. Now we are going to add the gravitational potential energy and the kinetic energy. The gravitational potential energy is mgh. The kinetic energy is half mv squared. Let's plug in the values. G is 9.8, but they are going to give you. You don't have to start now. If but can you forget G? They will give you. I think it should be here. The constant should be here. They always give you. It's here. 9.8. So you don't have to struggle with the constant. Okay, they will give you. So m is 3.5, 9.8, the height is 6. I put them in brackets, plus half, the mass is 3.5, the v is 22, but I square it using a calculator. 3.5 times 9.8 times 60, I'm getting 2.05.8 plus. So do we have anyone who has got a calculator? Because my calculator sometimes it performs, it can give us wrong answers. So do we have anyone who has got a calculator? So 205.8 is correct? Okay. So we do 22, we square it, times 3.5 times 1 over 2 is 0.5. I'm getting 847. Is that correct? $847. So if we add this 847 plus 205.8, I'll be able to get my total energy as this joules. Now I want you to, you know how MCQs are. They are so tricky such that you are going to find the answer for just potential energy only. So you'll be able to find the answer, maybe this one to be there, also this one maybe to be there, then this one will also be there, then another one is going to be away from the correct answer. So 1052.8, have you seen there is even 205, and if for 847, this is potential energy and this is kinetic energy. This one B we don't know, but the correct answer should be D, because D is closer to, we have found 1052.8, so D is closer to this joules. That's the answer. Tule mfano, we are getting there. Okay, let's go to question 6. Let's go to question 6. So question 6 reads, a helium atom of mass m collides. Mr. Newton's laws, are you in? He's not in. Okay, so a helium atom of mass m collides normally with a wall. The atom arrives at the wall with the speed of v and then rebounds. I want you guys to understand something. Whenever we are talking about whenever we're talking about linear motion, singa sevenza okowefakao. Whenever we are talking about linear collisions, linear momentum, sorry. Mm. Whenever we're talking about linear momentum, when you hear the word rebounds, then that velocity is negative. Does that make sense? That velocity is negative. As long as they rebounds, that velocity is negative. And I want you to understand that because mostly they are going to use that. So what it means is this. This question tells us that we have a wall. This is the wall. Now it is moving in this direction with a velocity of v. Rebounds meaning that after hitting the wall, it will start now going back. So when going back, it will go back with negative because it will be going against that guy. So definitely it's going to be negative. You get my point, okay? Definitely it's going to be negative. So now, this question, if we read again the question, so now just get it from me to say, as long as you read the question, then under linear momentum, they are mentioning the bouncing, meaning that the final speed is negative. That's what you need to know. So here now, the initial speed is just v, the final speed is negative v. Now here is the question, guys. A helium atom of mass m collides normally with a wall. The atom arrives at the wall with a speed v and then rebounds along the original path. So the same path, but it rebounds, meaning it was going now in opposite direction with the same path, with the same velocity as the initial, but in the opposite direction. That's why it's negative. Assume that the collision is perfectly elastic. Come on, guys. So let's talk about. There are two things that you are supposed to know under elastic. There's what we call elastic collision and inelastic collision. Let's talk about these two, guys. Elastic collision is a situation where two marbles, this is before collision, two marbles, that is before, after they collide, they are going to be moving with the separate velocity. So if this is m1 and this is m2, it has got v1 initial and this one has got v2 initial. These are going to have, this is still m2 or m1, this is still m2, then v1 but final, then v2 but final. So this is after collision. So after collision, the two marbles are going to be moving separate. That is elastic collision. And the formula goes like this. M1 V1 initial plus M2 V2 initial is equal to M1 V1 final plus M2 V2 final. This is the formula that we use under elastic collision. In a case where, but I think I've forgotten now. In a case where you plug in the values using this formula and you discover that you still have some missing variables, you still have some missing, you need an extra formula for elastic collision. We use this formula, V1 initial minus V2 or V1 final, then it should be equal to V2 final minus V2 initial. This formula is going to help you only when you plug in the values here. You discover that there are some, for example, you have got a question and it is elastic, then you have got two missing variables. This equation will come in. I think you have come across such questions, right? Rona guys, municho samo maziwa. Are you not dozing, Justin? You're in danger. Oh, so muli danger imwe. Mm. Don't worry, guys. When are you writing your exams? 20 what? First week, the date. What's the date? December 1. Exam starting on 1, meaning it's going to be very simple exam. Okay. So now another thing that you need to know under elastic collision is that momentum is always conserved. Momentum is always conserved. At the same time, kinetic energy is always conserved. That is under elastic collision. Why is it conserved? Because there is no friction at all. After collision, the two marbles are going to be moving with separate velocity. Yeah, so that's what happens. So the momentum is always conserved, and then kinetic energy is also conserved. Now, let's go back to inelastic collision. Inelastic collision is a situation where you have got these two guys. This is before collision. After collision, these two guys will stick together. That is after collision, meaning that they are going to be moving with the same velocity. Now here, momentum quite okay is conserved. Momentum is conserved always, but kinetic energy under inelastic collision is not conserved. So when you read the question, then the question is saying after colliding, or maybe the situation is elastic, what should come in your mind is this formula. Okay, when we're talking about inelastic, what should come in your mind is m1 v1 initial plus m2 v2 initial is equal to, you add the mass m1 plus m2, then the velocity is going to be 1. That's how it is. Okay, so now another thing that I want you to understand under momentum is this. Momentum is equal to mass times the velocity, meaning that the change in momentum is equal to the mass times the change in velocity. Look at this, guys. Let's assume to say you are holding something and you want to throw it. As long as that thing is moving and it has got mass, that thing has got momentum. Okay, so physics is real. So when something, that's why now there is a relationship between the velocity and this thing momentum. When something is moving, it has got mass, it is moving, then it has got momentum. At the same time, it has got kinetic energy because it's going to be changing the velocity. Okay, so the change in momentum at the same time, it can also be mass times the change in velocity is v final minus v initial. Now in the case of this question, where it's saying a helium atom of mass m collides normally with a wall, the atom arrives at the wall with a speed v. So the initial speed, in this case, the initial speed is v, and then rebounds along its original path, meaning that the final speed is negative v because it rebounds. Assume that the collision is perfect elastic. What is the change in momentum of the atom during its collision? We are from talking about it here. The change in momentum is going to be this. So we have been told that, so we want to find the change in momentum. So it's m. Now the final speed, from what we have just come up with here, the final speed is negative v. Then the initial is v. I'll just replace. The final speed is negative v minus the initial is v. So the change in momentum is m, then negative v minus v is 2v. So the change in momentum is equal to minus 2 mv. But now we just get the magnitude. So the magnitude in that case will be the change in momentum is equal to 2 mv. And that becomes my answer here. So D is my correct answer. Panga sense, right? It's making sense, right? Yeah, it's making sense. So another thing is even the test that you the test that you wrote, you need to go through. Yeah, you need to go through as well. You need to go through. So we can go to question 7, or maybe there's someone who's got a question. Anyone who has got a question? Guys, that's not true. You can't all you can't tell me that you don't have questions. It's normal. At least. Hmm? Hello guys. You guys, are you dozing? Ah, my mama guys. Okay, let's look at question 7. So a grasshopper of mass 0.112 grams jumps vertically. It uses its back leg over a time of 0.02 seconds to jump, leaving the ground with the velocity of 3.0 meters per second. What is the average power developed by the legs of the grasshopper? So what I want you to understand is that as the grasshopper is moving, is jumping vertically, there is energy that is going to be gained. Now that energy that is going to be gained, because there is velocity, there is what we call kinetic energy. Now the kinetic energy that is going to be gained is the same as the work done. That's the best explanation, right? So as the grasshopper is jumping now from the ground going up vertically, the energy, because of the velocity we have, meaning there is kinetic energy, that kinetic energy gained, that kinetic energy that is going to be gained, that is the work done by the legs. So let's first know the formula for power. Power is equal to what? Is equal to work divided by time. So the work done in this case is going to be equal to the same as kinetic energy gained by the legs, like I said. So I need first to find the kinetic energy, that is going to be the work done. So kinetic energy is equal to half mv squared. So half, the mass is 1 point, so I need to change it to kgs. That becomes 1.2 times 10 raised to the power negative 4. The velocity is 3. Now I square it. So what answer do I get here? 0.5 times 1.2 times 10 to the power negative 4, then times 3 to the power 2. Is this answer correct? So I'm getting 5.4 times 10 raised to the power negative 4 joules. So then it becomes, it's going to be power there 5.4 joules divided by the time 0.020 seconds. So power will be equal to, this joules should be times 10 to the power negative 4, which is 0.00054. So you divide it by 0.20 like that. So you divide it by 0.020. So the answer that I'm getting is 0.0, what else I make, 0.027 watts. Now because all the answers are in scientific notation, I'll shift this one 2, meaning is 2.7 times 10 to the power negative 2 watts. So the best option is C. Okay, so me, I'm tired now, I'm even dozing. So what I want you to understand is that you can access all the solutions for this paper. We are revising for the exams, so we have actually solved all of these, and also more practice questions under the same topics. So just register with Transcended, don't hesitate, we revise together as we are preparing for exams. Okay, so we have also so what we're actually doing is we are explaining each question step by step, so that you understand. Even if they change the question, you'll be able to grasp the concept. So that's the basic idea. Otherwise, that is it for this video.